Hello and welcome back to our lessons. We have already been looking at functions extensively. We will shortly start looking at the specific types of functions, but before we do that, I would like us to just review the idea of a coordinate system, coordinates of a point, the coordinates of a point that lies within a line segment. Look for the modulus or the length of a line segment as well as the gradient of a line. This is stuff that you've done earlier in MYP4 and other classes, but we will assume that some of you have forgotten, so I want to start very briefly with that before we move on. Okay, so let's start. So what are we doing in this class today? We shall introduce the Cartesian plane or the Cartesian coordinate system. We will review or remind you of how to find the coordinates of the midpoint of a line segment. And then we'll also extend slightly and find the coordinates of any point on a line segment. That is to say, the coordinates of a point that is not necessarily in the middle of, between 2 points, okay? All right, so we start by introducing the Cartesian coordinate system. Sometimes the Cartesian coordinate system is called the rectangular plane or the rectangular coordinate system. If you check your calculators, it will be referred to as the rectangular system, okay? The rectangular system was presented in 1637 by this gentleman called René Descartes. It consists of a two-dimensional square grid, all right, such as the one that is shown below. I have put that as a star because we are saying a two-dimensional. Today we know that we can extend this to 3 dimensions. So remember, we are working in 2 dimensions now, but we will extend this to 3 dimensions, okay? So this consists of a two-dimensional square grid such as this. It has got a horizontal line on it, which is referred to as the x-axis, and a vertical line that we normally refer to as the y-axis, okay? Where the x-axis and the y-axis intersect, that point is referred to as the origin, and it has what we call coordinates 0, 0. We'll talk about what coordinates mean. Any point on this plane is specified by a pair of real numbers, okay? And these real numbers will represent the distance of point P from the x and the y-axis respectively, right? Which is to say that point A, that the number A represents the distance of point P from 0, the horizontal distance of point P from the origin. So that is what is A, and B represents the vertical distance of point P from the origin, like this, okay? So that distance there is what represents A. So the value, it's called the x-coordinate, is the distance of point P from the origin. So that whole distance there is represented by letter A, or x of P, all right? And similarly, the distance B there is the vertical distance or the vertical height of point P from the origin, okay? So that is how we represent the coordinates of a point, okay? Note that if a point has coordinates AB and this point is on the x-axis, then the value of B is always 0. In other words, anywhere on the x-axis, the y value is always 0. For example, that point there has coordinates -3, 0. Okay, the x-coordinate is -3. Each square grid represents 1 unit, so that is 1, 2, 3, and we are on the negative side, and so that is -3. And because the y-coordinate is 0 around there, or in other words, point Q has not gone anywhere above or below below the x-axis, the y-coordinate there is going to be 0. So anywhere on the x-axis, the value of y, or that B there, is always equal to 0. Here is another one there. So the coordinate there is 5, 0, meaning that the y-coordinate is 0. The value of B there is 0. Okay? On the x-axis, this is important. This is going to be very important in functions when we look at graphs of function. Okay, we look at the x-intercept and the y-intercept. Anywhere where a graph crosses the y-intercept, the value of x there is always 0. Anywhere where the graph crosses the x-intercept, the value of y is always equal to 0. That's going to be very, very crucial in our study. Okay, so you can see there that point S is such that the x-coordinate is 0. Anywhere on the y-axis, the x-coordinate, the value of a there, is always equal to 0. Okay, similarly you can see point P there, the x-coordinate is 0. So in conclusion, anywhere where a line or any point that lies on the x-axis, the y value is always 0, and any point that lies on the y-axis, the x-coordinate is always equal to 0. All right, let's move on. Let's see if you understand this. I am timing myself so that we don't go past 5 minutes. Let's see if we understand. Check your understanding with example 1. State the coordinates of each of these points. Okay, what I want you to do is to pause the video and test your understanding. Okay? Well, if you've done this correctly, then your answer should be as follows. The coordinates of point P is that, coordinates of Q, coordinates of R, and the coordinates of point S are given. Okay, hope you got that. Let's see the next one. Example number 2. Plot the following on a copy of the XY plane. In other words, take a piece of square grid, mathematics papers or mathematics book, and sketch this. Plot the following points there. Once again, pause the video and check if you can plot this correctly. If you've done so, then I expect you to have done the following. Okay, so the coordinates of point P must be there, -3, -3. The coordinates of Q is there, 3 minus 1. Coordinates of R is 1, 4. That means move 1 step in the x direction, followed by 4 steps in the y direction, like that. Coordinates of point S, move 2 steps in the negative x direction, followed by 6 steps in the positive y direction. So those are the coordinates as expected. Okay, let's move on. A line segment. Let's talk about what we mean by a line segment and how we notate this, right? A line segment is any line whose endpoints can be seen within the square grid, right? Locally, in other words, in the graph that we draw it in. If the line goes beyond what we can see, you can't refer to it as a line segment. We will refer to it as a ray instead, okay? So a line whose endpoints are within the visible grid is referred to as a line segment. So here is our visible grid, and if I draw that line there, line AB is a line segment because we can see the endpoints A and B. Similarly, line CD is a line segment because we can see the endpoints, okay? When we refer to line segments, we use mathematical notation. The IB uses this symbol here for a line segment, okay? Academic programs use the AB with a horizontal line at the top there to represent line segments. So whichever program you are in, academic program you are studying in, these are the symbols that are commonly used. Of course, sometimes an examiner might just write line AB. Instead of saying line AB, they'll just put L there and say that's line L1, for example, and this would be maybe line L2, like that. So we can use just letter L, capital L or small letter L there to represent a line. So we don't have to use the C and the D there. We can use that to represent the line, okay? Right, moving on. Another thing we need to know is how to represent the length, the notation for the length of a line segment. So line AB, if we mean to represent the length of the line rather than just the name of the line, so this is just the name of the line, but if we mean to determine the length, the actual size of that line, then we use those two vertical lines there, which we refer to as the modulus symbol, right? So the modulus or length of line AB there is 4 root 2, which is approximately 5.6, slightly more than 5.6. The length or the modulus of CD is the square root of 65. We're going to discuss how we find these values if you don't already know how to find them, okay? So my interest here is the symbol, the notation that we use to represent this. So these symbols are used to name the line, and that symbol is used when we are looking for the length of the line, okay? All right. The coordinates of the midpoint of a line segment, all of us hopefully already know this. We will discuss it in a way that even if you didn't know it, it will come back to you, or you will know it eventually. The x-coordinate of the midpoint, we'll start by looking at how to find the x-coordinate of the midpoint of a horizontal line, right? So if we have a horizontal line, let's draw a horizontal line such as that one there, and we wanted to find the point smack in the middle, which is somewhere there. If we wanted to find the midpoint of that line, I am hoping that most of you already know that all we have to do is add the x-coordinates of A and B and divide by 2. It's kind of like saying the mean of the value of x. Since it is in the middle, the average or the median, okay, we find it by taking the x value there, adding the x value there, and dividing by 2. Okay, so hopefully all of us know how to do that. And if we do this here, we see that the the x-coordinate of the midpoint of line AB there is 1. All right. Similarly, the y-coordinate of the midpoint of a vertical line. So if I have a vertical line and I wanted to find the midpoint or the coordinate of the midpoint, we can find the y-coordinate. Notice that the x-coordinates remain the same. It is the y-coordinate that is changing. So we are looking for the coordinate of some point there in the middle. Of course, we can look, since we have this grid here, we can look directly and see that it is -3, approximately -3.2, I think, or something like that. But I want us to use mathematics to find this. So to do so, once again, all we need to do is to take the value of the y-coordinate of point A, add to the y-coordinate of point B, and divide by 2. All right? So if that's the midpoint, then what are the coordinates? So y1 or ya plus yb divided by 2. If we add those together, -1 plus 5 divided by 2, we get 2. So the y-coordinate is going to be 2. And so the coordinates of point M are going to be -3 and 2, because the y-coordinate is 2. Hope this is all fine. It's just a review of material that you should already know. Okay? So the coordinates of the midpoint of any line segment, all right? We want to find the coordinates of the midpoint of any line segment. So we've looked at the coordinates of the midpoint of a horizontal line and for a vertical line. What about if the line is neither horizontal nor vertical? So here is a line, our line AB. Now it is not horizontal and it is not vertical. Well, to find the coordinates of a point in the middle, we use the same ideas that we used with the horizontal line and the vertical line. And that is, we reason that if that's the midpoint, then to come from point A to point B, we must move horizontally. So there is a horizontal movement followed by a vertical movement, like that. Okay? So to find the x-coordinate of the midpoint, I have to use the same ideas with this horizontal line. And to find the y-coordinate, I have to use the same ideas for this vertical line, okay? And so, if I'm going to find the x and y coordinates, so this is the x-coordinate of the midpoint, and that's the y-coordinate of the midpoint, m there for midpoint, okay? Then I have to use that same formula. this part was used to determine the coordinate of the midpoint of a horizontal line, which will be this one here, and this was what we used to find the coordinate of the midpoint of the vertical line. So if we combine that and that, we will find the coordinates of the midpoint of line AB. We'll find the x coordinate, we'll find the y coordinate as such. So the x coordinate, we're going to take minus 4 plus 2 and divide by 2. So minus 4 plus 2 divide by 2. And the other one is going to be minus 3. These are the y values. Minus 3 plus 5 divide by 2. And if we do that, this is negative 2 divided by 2, which is negative 1. And this is 2 divided by 2, which is 1. So I expect the coordinates to be negative 1, 1. Okay, so the coordinates of the midpoint of line AB, where A is minus 4, minus 3, and B is 2, 5, the midpoint, coordinates of the midpoint are negative 1 and 1. All right, I'm hoping you are understanding this. And now just a reminder, if you did not know this already, hopefully you know how to find the length of a horizontal line segment or the length of a vertical line segment. Okay, this is a by the way because we are using it in the next step. If we are given a horizontal line segment and we know the end point, we know the coordinates of the end point, then we can find the length of the line even if we didn't know, even if we didn't have a grid. Now here we have the grid given, so we can tell that the length is actually 4. But if that grid was not given, we can still find the length of that horizontal line. And how do we do that? We take the x coordinate, since this is horizontal in the x direction, so we take the x coordinate of the last point and subtract the x coordinate of the first point. Okay, and that is to say, you can say x2 minus x1, or you can say xd minus x of c. All right, so that is 5 and 1 there. So the length of line CD is going to be equal to 5 minus 1, which is going to be 4. And that's how we find the length of that line. Okay. Ideally, this is supposed to be a modular sign here because we are looking for the actual length. So the modulus of line CD there, this is supposed to be a line because we are looking for the modulus or the length of the line segment. So the modulus of that line segment then is going to be equal to 4. All right. Now, I would like you to pause the video and find the modulus or the length of the following line segments. There are 3 of them. Pause the video and check if you can find them. Assuming you've done so, right? The length of the lines are as follows. So the length of line AB is 7. The length of line EF is also 7. So AB should be 7 because we only need to take the x coordinates. So it's going to be 2 minus negative 5. So 2 minus negative 5 is going to be positive 7. Okay. So we can write here, one moment. So we can say here that AB must be equal to the x coordinate there of point B is 2, subtract negative 5 because this is the x coordinate of point A there, and this is 2 plus 5, which is 7. So this is how we arrive at that 7. The same can be done with the other lines. The same is true for the other lines, and so if you've done this correctly, you should find that AB is 7, that EF is 7, and that GH is 5. Okay, so because these lines are vertical, you are subtracting the y values. If it is horizontal, you're subtracting the x values. Please remember how to find the length of a horizontal or vertical line segment. It's going to be useful in the next steps. We want to find the coordinates of any point on a line segment. We've learned how to determine the coordinates of the midpoint of a line segment, but what if that point is not the midpoint? Okay? In order for us to do this, we need to understand how these formulas come about. All right? these are the formulas for looking for the midpoint. How do we arrive at these formulas to use them to determine the midpoint of a line segment? If we can understand where these formulas came from, then it becomes easier to understand how to find the coordinates of any point on the line segment. Okay, so let's look at how we really find the x coordinate of the midpoint of a horizontal line. Okay, let's just concentrate on this one. How do we find this formula for the midpoint of a horizontal line segment? Okay, here is a line segment. We'll call it AB. So AB, the x-coordinate here is XA, and the x-coordinate at point B is XB. Okay, now remember that the coordinate represents the distance of that point from the origin, the horizontal distance from the origin. Okay, so we know XA and we know XB. So those are the coordinates of the x-coordinates of the endpoint. Since the line is on the x-axis, the y-coordinate is definitely 0, but we are not really interested in the y-coordinate. We are looking for the x-coordinate. Okay, now we want to find the coordinates of the midpoint, and there is the midpoint. Let's call it point M. That coordinate, point M, we will refer to as xm. It refers to the distance from the origin all the way to point M. Okay, we want to know the coordinates of xm in terms of xa and xb. We want to show that this formula is true. Okay, now we go by reasoning. What we are looking for is xm, meaning the distance from the origin to the point M. Okay, this is the distance we are looking for. If we find that distance, OM is actually the value of xm, because xm, the coordinate, refers to that distance from the origin. But OM, the distance OM, can be found by adding OA and AM. Okay, like that. So OM is actually OA, which is that much, plus AM. Now, we know that M is exactly in the middle of A and B, of the line AB. So because it is exactly in the middle, the length AM must be half of the length AB. And the length AB from the what we did earlier to find the length of a line segment, you take the last point, subtract the initial point, right? So we are going to find OM by taking OA and adding AM. Okay, I've just repeated the diagram. So remember that the length of line AB is the x-coordinate of point B, subtract the x-coordinate of point A, like that. All right? And so OM then, since M is in the midpoint, AM must be a half of AB, which is a half of XB minus XA, like that. So then OM is OA plus a half of AB. If we substitute what these things stand for, OM refers to the distance, the x-coordinate of point M. So this will be replaced by x of M. X sub M there must be equal to OA is this distance from here to here, which is the x-coordinate of point A, like that. And then we must add half of AB. So that must be half of AB, but AB is this thing here. So I can say plus half of XB minus XA. Okay, if I open the bracket there, I'll get a half XB minus a half XA. Let me just look that back. Let's look at it again. So if you open the bracket and put the half inside, we have a half of XB minus a half of XA, which gives me that. And now I can combine the like terms. This is x of A and this is x of A. So 1x sub A minus a half x sub A leaves me with a half x sub A. Okay, so it's a half x sub A plus a half x sub B, like that. Okay, you can slow down the video or speed it up if this is something that you already know. If you're looking at this for the first time, then you can slow it down. Okay, no problem at all. Well, if we combine this, if we add this together, adding fractions, we will end up with that. So it's XA plus XB divide by 2. If you understand how we've come up with this, it becomes easier to determine the coordinates of any point on a line segment. If we can follow that reasoning, then it becomes very easy to find the coordinates of any point here. It can be a point there, anywhere there. It can even be beyond B or before A. It becomes very easy now to determine the coordinates of any point, okay? All right, this idea is going to be useful also later when we study vectors, okay? So an HL topic on vectors relies heavily on your understanding of this to proceed. But let's move on. Check if you've understood what we are discussing here. We are still talking about the midpoint of a line segment. Find the x-coordinate of the midpoint of line AB there. So we have a line AB. What are the coordinates of the midpoint? Please pause the video and check and try to solve it yourself. Assuming that you have done so, this is very easy. We are looking for the coordinates, the x-coordinate of the midpoint. So the x-coordinate is just xa plus xb divided by 2. X of A is 1 and x of B is 9. So that is 1 plus 9. 1 plus 9 divided by 2, which is 10 divided by 2. So the x-coordinate of the x-coordinate of the midpoint must be equal to 5. Okay, here's another one, example 2. Find the coordinate of the midpoint of line L. So here is a line L. The starting point, call that A if you like, has coordinates 1, 2. Point B has coordinates 5, 12. Find the coordinates of the midpoint of line L. So now it's not horizontal and it's not vertical, so we must find both the x and the y coordinate of the midpoint. To do so, please pause the video and try it yourself. If we assume you've done so, then this is how we go about this. Put down the formula for calculating the coordinates of the midpoint, and that's what it is. All right, the coordinate, the x-coordinate of point A is 1 and the coordinate of point B is 5. So we're going to have 1 plus 5 here, and we're going to have 2 plus 12 here, like that. 1 plus 5 and 2 plus 12. That is 6 divided by 2, which is 3. That is 14 divided by 2, which is 7. And so the coordinates of the midpoint of this line is 3, 7. Yes? Hoping that is okay. Here are some practice exercises. Practice exercise A. Find the coordinates of the midpoint of the line segments with the stated endpoints. So here are the 3 lines. Okay, those are the coordinates of the endpoints of the 3 lines. Please find the coordinates of the midpoint. Pause the video and do it yourself. So if you did this correctly, this is what you should find. All right, so check that you got the same answers as I did. If you didn't get these results, then something is wrong. You can ask me and I can go through the problems with you. Okay, right. Okay, so now let's go straight into finding the coordinates of any point on a line segment. Okay, so let's start with the horizontal line. Okay, can we find the coordinates of any point between the points A and B on a line segment? All right, so we have a line segment AB. The coordinates of point A are XA, Y, and XB, Y. So the Y values are the same. It's the X values that are changing. Okay, now what if the point of interest is not the midpoint? We now know how to find the midpoint of the line segment. But what if the point, we are interested in some point, P, is not the midpoint? Consider the point P on line AB so that AP to PB are in the ratio of 2:3, okay? So the x-coordinate of our point, the coordinate we are looking for is XP. Right? So if point P is on line AB in such a way that the ratio, so there are 2 parts here to 3 like this, okay? so that's the ratio in which they are divided, then you can see that AP takes 2 parts of the total 5. PB takes 3 parts out of 5. So we can say that AP is 2/5 of AB. Okay, this is very important, right? So that distance there, AP, must be 2/5 of AB because it is 2 parts of the total 5 parts. So AP to BP split up that length in the ratio 2:3, which means there are 5 parts, so that AP takes 2 of them and PB takes 3 of them. And so the length AP must be 2/5 of the length AB, like that. And because of that, we can now reason that the distance OP must be the distance OA plus the distance AP. Okay? Now the distance OP, which is what we are looking for, is the x-coordinate of point P. So the x-coordinate of point P then, again, of course, remember, we are saying 2/5 of line AB, but AB itself is the x-coordinate of B minus the x-coordinate of A, right? So that should not be a big deal. So now we can say that XP, which is the distance we are looking for, must be XA, that distance up to that, okay, must be XA plus 2/5 of AB, like that, which when we put this XB minus XA here, maybe we should do it. Okay, let's just try to do it fast ourselves. So we are saying, right, so we are saying that we are saying we're looking for XP. And so XP must be equal to XA, which is the distance from here to here, plus this much. But this much is 2 parts out of 5 of AB. But AB is XB minus XA. So we need to find that. If I open that bracket, I get XA plus 2/5 of XB minus 2/5 of XA. Now I have an XA here and I have minus 2/5 of XA. So I can say then that my answer is that XP, the x-coordinate of point P, must be this, my 1 XA is the same as 5 out of 5 XA. So 5 over 5 minus 2 over 5 must be 3 over 5 XA. Okay, let me try another pen. And this is going to be plus this one here, plus 2 over 5 of XB. So we end up with this, which I can rewrite, but we'll see how to rewrite this on the other end, right? So this is the process that we use to determine this value. We will let's just see this in a neater kind of form. I'm going to erase this so that we look at it better. Okay, and so XP then becomes, so XP, that distance there, becomes XA, which is this much, and we have to add 2/5 of AB, like that. So AB is the same as XB minus XA. When we open the bracket, that's what we get. And so 5 over 5 XA. 1 is the same as 5 over 5 minus 2 over 5 XA. So that's going to give us 3 over 5 XA. And then we say plus 2 over 5 XB. So we end up with that. And of course, if we put that together, if we combine that, we will get 3XA plus 2XB divided by 5. One of the things I need you to notice immediately is that this is the side A and that is the side B. And this is 2, let me write this here. So this is split into 2 here. So this bit is 2 and this bit is 3. When it comes down, when you look for it, the 3 actually goes to the side A, and the 2 goes to the side B. And this will be seen as a pattern that appears throughout. Okay, and so that is how we find the coordinates of point P if it is split up in the ratio, if it splits up length AB in the ratio 2:3. So what comes here depends on the ratio in which P splits the length AB. Okay, so here is an example. You can pause the video, but let's put, so here is a line AB with coordinates given. Okay, the coordinates of point A is 3, 1, coordinates of B is 8, 1, right? What are the coordinates of point P if P is splitting line AB in the ratio 2:3? Okay, pause the video and try it out. If you've done so, then you can see well, all that is happening is we are taking the coordinates of the x coordinates of A and B and plugging them in here. So the x coordinate of point A is 3 there, and the x coordinate of point B is 8. So plug in 3 and 8 there, and we have 9 plus 16, which is 25 divided by 5. 25 divided by 5 is 5. Okay, so the x coordinate of point P there has to be 5. Okay, so that P is not the midpoint, but we were still able to find its coordinates. Okay, right, here is an exercise for you to try out. The point A, B, and P are on a line segment AB so that the coordinates of A are given, the coordinates of B are given there, and AP, the ratio of AP to PB is m:n. The question is for you to show that the coordinates of point P, the x coordinate of point P is given by that, or it is given by that formula there. Okay, so I want us to do this. I want you to try it out. If you're not able to do it, let me know and I will take you through it. But it is effectively the same thing that we've done as before. All right, we are looking for the x coordinate of point P there. So we are looking for the x coordinate here. Okay, by the way, pause the video and try it out first. If you're not able to do it, then you can come back and look at what I'm doing. All right, so we look for the x coordinate of point P. That's what we are looking for. Let me create some space there. All right, now the x coordinate of point A here is x A, and the x coordinate of point B here is x B. Now we are looking for the distance from the start to this point, which is xp. So the distance from the origin, you can say OP is equal to OA plus AP. So I can write OP must be equal to OA plus AP, right? OP is XP, which is XA plus M over M plus N. It's a fraction, like we had 2 out of 5. This is now going to be M over M plus N. So a fraction M over M plus N of AB. But AB is X of B minus X of A, like that. Okay? So when you open this bracket, I think I can stop there, or maybe I continue a little. This is going to be X of A plus MX of B over M plus N minus mx of A over m plus n. Okay, like that. And this is m plus n over m plus n of A minus this is going to leave me with, so this minus this is going to give me n. Okay, because this is, let's see if I can do it here. This is the same as m plus n over m plus n. In other words, 1a x, okay, that of xa, and we are subtracting m of xa over m plus n, and then we will add m of xb over m plus n, and you can see that this is in fact m plus n. If we subtract m, we are left with n. So this is n xa over m plus n, and plus m xb over m plus n, like that. We can put this together and it becomes n xa plus m xb, everything divided by m plus n, like that, and we have shown that the statement is true. Okay? Okay? And so we have shown that this is true. Let's move on. Here's another practice exercise. Again, you will pause the video and see if you can answer this. Point P lies on the line segment AB as shown. There's a point P there, I've not indicated where. Find the coordinates A and B given that P is the midpoint of AB. So if P is the midpoint of AB, what are the values of A and of B? Okay, part 2 is if P lies on AB so that AP to PB is 1:3. So let's start, pause the video and try it out, of course, yourself. And assuming that you have done so, let's see how to answer this question. Okay, so let's start with the first case in which point P is the midpoint of AB. So if point P is the midpoint of AB, then it's very straightforward. Then the coordinates of the coordinates A and B must be found from the formula as such. So the x coordinate is found from that formula, the y coordinate is found from the similar formula there. We know that x of A is -1 and x of B is 7. All right, y of A is -3 and y of point B is 5. And so what we have here must be -1 plus 7 there, -1 plus 7, which is, so -1 plus 7 is 6, divided by 2 is 3. And here we have -3 plus 5, which is 2, and divide by 2, which is 2, divided by 2 is 1. And so the coordinates of point P must be equal to, so A must be 3, and B must be 1, like that. Okay? What about if point P is splitting AB in the ratio 1:3? So here is part B. So AP is to PB is 1:3. What are the coordinates of point P? Here is the diagram for this. So we have this split into 4 parts. So 1 and 3 gives us a total of 4 parts, so that AP should take 1 part and PB should take 3 parts. Okay? So there is our P now. So then in the x diagram, so we are doing the same thing using the same formulas. Remember the formula for this. So the ratio is 1:3. So when we come here, so if this is M and that is N, the N comes to this side and the M comes to this side. If you remember the formula that we used for this, okay, our formula was, the formula we came up with was that the x coordinate of point P must be, if this is M, this is our M here, is to N, then this must be N of XA plus M of XB. In other words, they switch those ratios and then everything is over M plus N. So keeping that formula in mind, so the x coordinate of point P is given by that, and the y coordinate of point P must be given by that. So the 3 and 1, well, the 1 and 3 that was given as the ratio, we put them back there. And so for x coordinate, all we need to do is to plug in the x values and the y values. So the x values for point A is -1 there, and for point B is 7. So this is going to be 3 times -1, which is -3, and this is going to be 1 times 7, okay? And so we end up with -3 times 1 plus 7. And on the other side, we will have -3. So 3 times the y value there is -3, plus 1 times the y value here is 5. So it's going to be 3 times -3, which is -9, plus 1 times 5, like this, which is just 5. And so that is 7 minus 3, which is 4. 4 divided by 4 is 1. And this is -9 plus 5, which is -4. -4 divided by 4 is -1. So we expect our values to be 1 and -1, okay? So the value of A is 1 and the value of B is going to be -1, right? Master this so that when we get into vectors, this will become, issues related to these ratios become very, very easy. Okay, so in summary then, what have we learned today? We've learned that we can find the coordinates of any point in addition to the other things we discussed, that we mentioned. We've learned today that it is possible to determine the coordinates of any point on a line segment, provided we know the endpoints of the line segments, okay? So if we know the endpoints of a line segment, if we know the coordinates of A and we know the coordinates of B on line AB, and there is a point P on line AB that splits them in the ratio AP to PB equals M:n, then the coordinates of point P can be determined easily. So here is our point P. The coordinates of point P can be determined easily according to that formula there. Okay? That is the big deal of the discussion we've had today. I'm hoping that you got this right. If you have any questions, please put it in the comment section. Otherwise, this will be the end of part 1 of this discussion. We have a long way to go, but this is the first part of it. This is not really MYP5, this is a lower class, but we have to review it in order for us to progress with the parts that we need to discuss in MYP5, okay? So hopefully you are able to understand what's going on here. If you found the video useful, please consider liking it, and as well as subscribing to the channel if you've not already done so. This way, when I post any new video, you will be notified beforehand. Okay, thank you very much. I'm seeing you in the next video shortly.